Hello everyone, welcome to my channel. Now in this part 2 of the proof of some special integral, we are going to discuss the other two proof of the integral. So I'll write this down. This is the third proof. Okay, so I is equal to integration 1 upon a square minus x square dx. Now we are going to solve this and we will see how we can arrive on the result. Okay, so for this, now what we will do, we will do the same method that we have applied for the second proof in the last video. We will split the numerator. Okay, so before splitting the numerator, we have to multiply 2a and 2a. We have to multiply and divide it by 2a, so that gives you a square minus x square again in the denominator. Now in the denominator we can apply the same formula as a square minus b square, that gives you a plus x and a minus x dx. Okay, so the next step will be splitting of the numerator so that your denominator gets splitted. So that will be 1 upon a plus x minus 1 upon a minus x. Just make sure that these two terms will be in the denominator, but what will come first and what will come the other with the plus and minus sign in between, you can check it in your rough work. Okay, and then you can do it here. Now if you can just do the cross multiplication, you will see that you get the same result in the numerator. Okay, now we will apply the integration formula to both of this term. Also we have the linear term in the denominator of both of this term, so we can apply the log formula, that is log of mod of a plus x minus log of mod a minus x with the bracket plus c. Okay, 1 upon 2a, again this is log of a minus log of b, that gives you log of a upon b, that is log of a plus x upon a minus x plus c. So this is how you can prove it. It is a very simple proof. Okay, with the couple of practice you will be able to do this. Okay, now we'll move on to the next one, which is I is equal to integration 1 upon square root of a square minus x square dx. Now we'll see how we'll solve this. So for solving this, we will take a help of trigonometric ratio again. Put x is equal to a sine theta, taking the derivative on both sides, so that will give you dx. A is a constant, we'll keep it aside. Derivative of sine is cos theta and d theta. Okay, also we are going to find the value of theta. Theta value will be sine inverse of x upon a. You can just write it over here because we are going to take a help of this theta. Okay, now let's just substitute over here 1 upon square root of the value of x square will be a sine theta. Okay, so a sine theta square, and the value of dx will be a cos theta d theta. Now again the integration 1 upon square root a square minus a square sine square theta under the root, okay, cos theta. Then you can see a square is common in both of this term, you can take the a square as common, that gives you 1 minus sine square a cos theta again. So here I will be equal to 1 upon the root of a square will be a, and again the root 1 minus sine square is nothing but cos square according to trigonometric identity. We already know, I'll write it here. Sine square plus cos square is equal to 1. Okay, and here in the numerator we are left with a cos theta d theta. So we'll solve this. The root of cos square is cos, and this is also a cos. The both term will get cancelled with the denominator, so we are left with only 1, and the integration of 1 is nothing but theta, because we are doing it with respect to theta, plus c. Now we can find the value of theta over here, that is why we have found it there, that is sine inverse of x upon a plus c. So this is how we have proven this formula. Okay, so we have done the two proof in this video. Just practice it, it may come for your board exam. Okay, and also watch the part 3 video for the other 3 proofs. Okay, thank you for watching this video. Have a good day.